Good morning everybody. Today now we are at the last session, that is sixth session of Film 2 Food Processing Engineering and Technology. Last theme is utilization of food processing works and newer processing technologies. I welcome Dr. Aarti Patil sir, former director Sri Ludhiana, and I also welcome Kapoor sir, former dean PS College of Agriculture Engineering and Technology PS KK Tapoli. I also welcome Dr. Devkar sir as a reporter. Now I request Dr. Aarti Patil sir, Head Department of Extension, College of Agriculture, GNMP Patani, to welcome our honored guest Dr. Aarti Patil sir. I also request Dr. Kadam sir to welcome our respected Sir Engineer Kapoor sir by offering bouquet and memento. Thank you, sir. I request Dr. Aarti Patil sir to welcome our director sir by offering bouquet and memento. Thank you, sir. Now I request the chair to continue the session, please. Thank you, sir.
Very good morning, distinguished delegates. I see all full of people I see here. And this is the last session. We have to be very quick. We have a few presenters here. And there are some lead papers. Is it not? It is not audible? Very good morning. Very good morning. And then we are going to start the last session, which is about food processing, engineering and technology. And we have voting papers. We have been instructed to finish it by 9:30. So we have 1 hour or 1 hour 15 minutes. And then we have very interesting topics to be listened and discussed. Thank you.
I also take this opportunity to welcome you all for our today's presentations. Though it is the last session, but equally important because there are so many topics which would be very useful for all of us. I just want to confirm whether all the presenters are there in the hall. Is Mr. Sakaram Kande or Kande or BD or Javlijit Kar? Anybody? Then Namrata madam is there. Then Praveen G. Yam, IP Saudagar, R. Kandi Selvan, T. Rajkumar, T. Arul Mani or T. Bhavana. Anybody present? Oh. Yeah. Then Anki Kumar, B.S. Rao, Sunil Kumar, Bhavya, Vijayan, Kritika Samu and Vikas. Anybody from there? Four. Then Rishikesh Patil, Ravindra Naik, Suresh Kumar, Param, Shivam and Then Archana Mahapatra, Sandeep Kumar, Priyanka Sakre, Arnab Roy, Chaudhary, Saroj Kumar, Giri and Abhijit Kar. Anybody? Then PC Vendaya, Kia Prasad. Yes. Then Vishnavi A, Dayakar B, and B. Available. Then Archana Vaidal, Uday Kumar Miloni, Ramappa. Is it presented? Ramappa KT, Amish Ganachari, Saroj Rao, and Nagaraj Naik. Anybody from them? Available. Then Cherpe AM and Gitanjali Kamble. No. Then Ajay Chaudhary, yes, Anand Kumar, M. Loganathan and M. Kijon. Available. Then Rahini P, yes, Anand Kumar, Ashish Rautan and R. Jagan Mohan. Then Mathala Juliet Gupta, Dheeraj presented. Okay. And one is online. We have 3 online registrations. Okay. 3, 6, and 14. 1, 2, 3, 4, 5, 6. 6 regular.
Good morning. I welcome you all the delegates in the 6th session of food process engineering and technology for utilization of food processing waste and neural processing technology. So I would like to call upon first optimization and characterization of pectin extracted from Palmyra palm fruit pulp using response surface methodology. Dr. P.C. Vengaya.
Dr.
Time.
Vengaya, you have 8 minutes and combine both your presentations together and tell the people about what Palmyra is about. Okay, thank you.
Respected Chair and other delegates, good morning to all. Sir, myself Vengaya from Dr. YSR Horticulture University, Andhra Pradesh. I am working in Palmyra Farm. Next. Sir, as you all know, Palmyra is the almost it covers entire South India up to South Bihar. It is estimated that it is more than 150 million palms are available in India, and but nobody working on this. Although it is having a, if you see sub themes of our food processing technology, all teams can work in one palm itself, sir. There are scope for plenty of opportunity to work in this area. Specifically in this paper, it is a Palmyra fruit pulp, sir. From each palm, it is around the average of 100 to 150 fruits per year. Each palm gives, and each fruit gives around 300 grams of pulp. If we, from 2 million palms, it is tons of pulp is available, but nothing is using as right now. But it is delicious and very rich in nutrients. So just next I will show my paper different products. Sir, here just attempt was made in some commercially useful product, that is a pectin extraction with CCRD. Some trial was made during the last season. That simple process with constant pH and the different temperature and timing, and with RSM that pectin was available with optimized pectin, sir. In this found that pectin is available.
Conclude the results.
Yes, sir. Yes, sir. Yes, sir. Optimized condition is it is 180 minutes and 90 degrees temperature. That pectin is ranges from 5.8% to 20% pectin is available in dry basis of that Palmyra fruit powder, sir. And same was it is on par with other quality parameters of the AU value and other DU value, sir. This is about pectin extraction of the from the Palmyra fruit pulp, sir. Thank you, sir.
Okay. These are the fruits, Palmyra fruit?
Yes, sir. Yes, sir.
How big is that fruit?
Sir,
How big is that fruit?
it is around 1.5 kg to 2 kg, sir. Each fruit.
Each fruit.
Yes, sir. Then next presentation, just.
Ah.
Just I will go through, sir. I have plenty of suggestions. I will show what are the. So lot of scope is there. Another sector people are earning more, sir, but the lack of technology now not able to commercialize. That is the main problem, sir.
I think I would like to request you to give one or two recommendations which you would like to have.
Yes, sir. Yes,
This
sir.
one. So that Palmyra can be
The
popularized.
importance of yes, sir. So this is about as you all know, so it is one quotation from the autobiography of Mahatma Gandhi, sir. Palm sugar is an antidote of poverty in rural India, sir. And similarly is another quotation also given, sir. If you utilize the palms in rural, actually, sir, now in India almost more than 50% of villages covering the palms are available, sir. Naturally available, nobody to growing, and simply it is only harvesting and utilization, sir. That's why, but in ancient days, there are many literature shows that, sir, it is very much useful in agriculture also. It saves from the lightning, and it gives the water level, it maintains the water level of groundwater level. Like that, there are many in ancient literature itself, more than 800 uses from the Palmyra palm itself, sir. But due to some other reasons, now people are not utilizing properly. That's why just we attempted to, under part of my ASRP, these are the host for different birds, and these are some articles also in paper, how it saves, and it is working as a wind breaks, and there are plenty of use in agriculture also, sir. Like that, if you utilize 50% of palms itself, crores of rupees we can generate, and it will contribute in GDP, and we can employment in each and every village, sir. This is our farm at Pandri Mamidi, sir. We are having a ASRP palms, and we are maintaining 272 collections of germplasm to collected entire India, sir. Up to South Bihar we collected, and we are maintaining and we are evaluating germplasm, sir. And we are the resource center, and we have IC numbers from NPPGR, sir. It is estimated that more than 150 million palms it is in India. Mainly Tamil Nadu and Andhra Pradesh having a plenty of palms in each and every village. This is the different age-old palms at our farm, sir. And also we are just altered coconut climbers for Palmyra climbing. I myself also used to climb by using the standing type and sitting type climbers for tapping, harvesting. And people now, many people are climbing for their own purpose, sir. Last year itself, more than 50 climbers through the people are purchased their own purpose, both Palmyra and coconut they are using, sir. And this is the tapping also we standardized both male palm and female palm and fruit. Actually, sir, tapping only seasonally they will tap, but we standardize the different stage of tappings of male and female and from the fruit. Throughout the year we can collect the nira or toddy, sir. That way we standardized. And similarly, it is old technology for collecting the nira. They will keep the slaked lime in the pot, and they will collect the nira, and they will make it into the jaggery. It is an ancient method, and under support of KVAC, they are making jaggery in many places. Whatever palm jaggery available in the market, same jaggery, that is the old method only.
It is very expensive also.
Yes, sir, expensive also. This is then we try to collect the cool box technology. Then we standard the cool box technology in the CPCRA model as well as our own model. We have now that the cool box technology without adding any lime and all. The drop which is coming from the space directly into the cool chamber. In the cool chamber we will maintain ice or gel pack or electric pad for maintaining the cooling, and we now standardize the vessel for collecting the both male and female palms. Now we are planning to go for the patenting, sir. Now I am not showing here, sir.
CPCRI has patented it already?
Sir?
CPCRI?
Yeah, that is for coconut palm, sir. Now we have that Palmyra palm. It is the space, the size, and the different, sir. Yes, sir. This is the old, just Milton can itself we alter and we able to collect nera, sir. This is the fresh and original cold box technology nera. It is and 100% natural collected Nera, sir. It is delicious and tastes of around 14% and rich in iron as well as potassium, sir. Similarly, we studied the storage studies and different collection technologies. These are the different microbiological studies also we conducted for Nera and economics of Nera, sir. Each palm gives 150 liters average, sir. Some palms gives more also. If you see from each palm itself more than 15,000 rupees per year we can earn, sir. This much potential is there, sir. If we utilize the 10% palm itself, crores of rupees we can generate from the palmyra itself. And we established one pilot plant at our place for Nera based products, sir. Then we attempted in freeze drying also, sir. Now we are getting the just glucose like powder in different. Now it is under process of freeze drying also we attempted. Then another one different products, sir. Palm syrup. Here also, sir, male palm, female, and matured fruit also different type of quality we are getting, sir. This is the dark color syrup is from the male palm and it is from female palm, sir. Some same time of concentration of liquid jaggery around 69 bricks of syrup, sir. Similarly, it is a jaggery powder, sir. It is a male palm, female palm, and matured fruit, sir. 3 types of jaggeries we can get from the palmyra itself. Throughout the year, we can collect the Nera and we can make it out of jaggery, sir. It is 100% natural, sir. Nothing added, sir.
This matured fruit is just like coconut?
No, sir.
The meat, how it is meat?
I will show, sir. I will come.
Okay, just a minute.
This is the original jaggery, sir, without adding any lime and all. 100% natural. Nera collecting through the cool bath technology and making jaggery. This is the natural jaggery, sir. From jaggery, we can make different sugar and sweeter based products, sir. This is jaggery powder form, sir. And also we try to develop the crystallizers locally. Then this is the crystals of first grade, different grades, sir. I will go through, sir. This is a different type of jaggery samples. Now we are able to this crystals, jaggery powder and chocolates and syrup. And these are now we are selling in our own like YSR brands, Nera, liquid jaggery and jaggery powder. These are other products and homemade chocolates also from palm based. We tie up with some local self-help groups, sir. And this
Sir,
is the
come to the conclusion, sir.
yes, sir. Yes, sir. Then I will show different. This is our pilot plant, sir. This is the first kind of India from Palmyra products. We developed a pilot plant worth of 2 crores and RKV project. And for all Nera, jaggery, liquid jaggery, vacuum concentration unit, and palm sugar and jaggery of jaggery powder and fruit processing also, sir. And this is our working condition of the Nera processing in our unit, sir. And this is the jaggery unit with support of boiler. This is the traditional jaggery. Yesterday also I showed this one, sir. Sir, how much demand you can imagine by just wife and husband itself every year, 4 months around 6 lakhs income, sir. Just one family by making palm jaggery itself. It is a real example in our Andhra Pradesh, sir. There are different statistics, sir. Just I will go just to another part, sir. Tuber also. This is apicolan or tuber, sir. Now this is the season from Diwali to Sankranti. This is a big business in Andhra Pradesh in unorganized sector, sir. From this, only people are just frying in open fire or in inverted pot and all. They will eat directly, sir.
Tuber where it is available at the bottom?
Yes, sir. Bottom, sir. Then we made the flour by using the pieces and drying the dry and make it flour. And different we standards we have different bakery and confectionery items also, sir. Then from this also, sir, in from Andhra Pradesh, one village itself, they are exporting Canada, sir. That fresh tubers, sir. Then coming to the tender food endosperm, sir. This is also for dozen during the season, more than 100 rupees in the Chennai and Rajahmundry, Vijayawada, Hyderabad, sir. But plenty of potential is there, sir, processing. Then we attempted different flakes and osmodehydrated product and milkshake like that, different products, sir. When sprouting comes from the nut, it is a spongy endosperm also is rich in protein. This is also from where that health mix, and that copra also is very hard, and from this also out of also we make a chutney and all. These are the different, coming to the fruits, sir, just you asked, sir. This is the palmyra fruit, sir. From this fruit, we can pulp, sir. Inside 3 nuts, average, generally the 3 nuts will be there. And this is the fruit, and 3 nuts will be there, sir. Out of that pulp is there, sir. After pulp, we can get nuts. Then we can sow for nuts for germination, and fiber also available, sir.
Yeah.
These are the products from the pulp. We standardize the different blended with other beverages and palm leather and pomade dried flour and RTS beverage, sir. These are other snack items from the palmyra fruit itself, sir. Then coming to the economics, sir. Then out of other non-edible products also available, plenty of, sir. This fiber itself exported from the Kakinada port in now also, sir, in the only, but there is no processing, just fiber people will collect manually and separation like this, and this fiber is exporting to different countries, sir, and other different brushes and eco-friendly fiber also, lot of scope, sir. And on the leaf articles also, we are training self-help groups. I myself, we are trying to this all learn, and we are trying to self-help groups, sir. There are different scopes, sir. This is we are giving the tribals. Now we are giving the tribal people. Now we started health and wealth concept. There is no investment, sir. They naturally they are having a tapping skill, and plenty of palms are available. Just you collect the nira and you made it jaggery, and we trained ladies, sir. Now they are baking home itself, and whatever they are eating home itself, whatever extra we are purchasing and we are selling, sir. That's
Very
why-
good.
yes, sir.
Now we should thank you for
Sir,
this.
these are the products we are selling at our institute, sir. But due to so many concerns, just I know just 2 points, sir. Sir, other farms government is supporting like anything, sir. Suppose CDB, whatever we are doing, even plant growing also, they are giving 50% subsidy, sir. But for this farm, nothing is there, sir. Nobody is giving support. Even departments also sometimes it comes under which department? People are confused, sir.
I think you give the 2 points. We will put a very strong recommendation
Yes,
in
sir.
this.
And for my ISA, sir, I am requesting that all the food process scientists to work in this area, sir. Plenty of scope is there. It is naturally available farm. There is no investment. Even pulp, fruit, tender endosperm, nira, jaggery, fiber, leaf, and midrib. So many things, sir. To initiate research programs at all.
Yeah, that is what I was thinking, that
Yes, sir.
these different universities, they can think about giving the students this
Yes,
kind of
sir.
work.
Yes, sir.
Thank you.
That is yes, sir. And recently, Parliament also question raised, sir. We submitted reports, sir, that how we can best we can utilize in rural areas by utilizing these palms and all. We given submitted report through ICR, sir. Parliament also. Thank you, sir.
Now you can have a discussion. If somebody wants to ask you anything about it, we will not open it for questions.
Yes, sir. I am ready to give. Thank you, sir.
Namrata Ankush Giri. Title is Innovative Use of Pomegranate Processing Waste as a Natural Preservative in Functional Muffins, Enhancing the Shelf Life and Nutritional Value.
A very good morning, respected chairman, co-chairman, rapporteur, and all the delegates present here. Myself, Dr. Namrata Giri. I am Namrata.
You have 5 minutes.
Yes, sir. Yes, sir, I will complete my presentation before 5 minutes, sir. Yeah. So I welcome all of you to my presentation. The topic here for my presentation is innovative use of pomegranate peel powder as a natural preservative in functional muffins to enhance the shelf life as well as nutritional value. So with the background, as we know that whatever the commercial bakery products are available, particularly muffins, these are having the shorter shelf life, and these are preserved using the synthetic or chemical preservatives such as calcium propionate or potassium sorbate. Second thing, these bakery products are dense in calorie and lacks nutrition because of using refined wheat flour, refined sugar, and hydrogenated fat. And third thing is now consumers are very conscious about the health, and they are always demanding for the something healthy food product, and for that purpose food industries, they are looking for the product which act as a functional ingredient and that can be used as a bio or natural preservative. Another side, pomegranate processing industry, particularly the juice processing industry as well as aerial processing industry. From that industry, pomegranate peel, it's generating in a huge quantity as a byproduct or waste. But the beauty of this pomegranate peel is it is very rich in polyphenol content, then having high flavonoid and tannin content. Because of presence of this content, this act as a natural antimicrobial activity as well as having very high antioxidant activity. So that potential of pomegranate peel I am using in my presentation or in my research work, how the potential of pomegranate peel powder as a natural preservative used in the muffins to enhance the shelf life as well as its nutritional value. So I will quickly go through the mechanism, how this pomegranate peel act as having the high antimicrobial activity. The presence of polyphenols, flavonoid and tannin, all together these three acts on the cell wall of the microorganism. It will cause the lysis as well as reduce the ATP synthesis, and all that action together mechanism reduce the growth of microorganism. and shows the high antimicrobial activity. So with this background, we propose this project and we formulate the muffins by using the pomegranate peel powder around 8%, and we compare the developed product along with the muffins using chemical preservative, particularly potassium sorbate and calcium propionate. So these two preservatives are most commonly used, calcium propionate and potassium sorbate. We have added that quantity as per the FSSAI permission limit, which are most commonly used, and we compare its all the physicochemical property, nutritional property as well as shelf life. Then we have also determined what are the dominating microorganisms which are responsible for the spoilage of the muffins, and we find out that mostly Aspergillus and Penicillium, these two are the most dominating spoiling microorganism in case of the muffins. So with that background, we have studied the in vitro antifungal activity of pomegranate peel powder, and we compare its antifungal activity along with the chemical preservative, that is calcium propionate and potassium sorbate, in our lab, and we found that pomegranate peel powder almost acts at par and superior as an antifungal activity in comparison with the chemical preservative. With this concept, we have developed the product and we compare its all the property. So here you can see that we have determined all its physical properties of muffin batter with respect to viscosity, color value, specific gravity, as well as we have also studied its optical macroscopic structure. Then physicochemical property, here you can see that due to the addition of pomegranate peel powder, there is increase in crude fiber content as well as reduction in carbohydrate content, the things which all are preferring, like product should be low in calorie, and it will also shows the very increase in the bioactive component with respect to phenols, tannin, and show high antioxidant activity. We have also studied its microscopic structure, which shows that due to the addition of pomegranate peel powder, there are certain changes in the morphological structure of the muffins. Then since from the first section of this theme, we have studied that whenever we are doing any fortification, there is a need to study how much retention of the nutrients is required after consumption of that product, and we studied its bioaccessibility of the product along with the glycemic index, and we got very good result, and it shows that due to the addition of pomegranate peel powder, there is a maximum retention of the bioactive compounds. In conclusion, you can see that around 1.32 times phenols, 2.3 times flavonoids, and 8.8 times antioxidant activity is released or retained in the intestinal phase of the human body. We perform all this study in vitro condition, and we have also determined the glycemic index, and that is very good things. Whenever we are adding pomegranate peel powder as compared to the control sample and commercial sample, its glycemic index reduced, and it will comes under the medium GI food. We have also performed sensory evolution. It is also at par along with the control and chemical preservative muffins. During storage study, we found out that due to the addition of pomegranate peel powder, there is a retention of the moisture content because of high fiber content of pomegranate peel powder, which is a desirable things. And microbial study shows that here you can see that control sample gets spoiled on 7 days itself, but other sample like sample with the peel powder and chemical preservative, they are almost at par, and it clearly shows that we can completely replace the chemical preservative with the pomegranate peel powder. And here I would like to finally conclude that the pomegranate peel powder can be used as a natural preservative, not only in the muffin, in other food product also, and it will also enhance the fiber content. We have also come up with some good publication from this research work having more than 4 impact factor. Thank you so much.
Any question? Just one question.
Is the technology available? Yes, excuse me, madam.
Yes, sir.
Here, this side.
Yes, sir.
Yes, sir.
Actually, we want to use your technology, is it available?
Yes, sir. We have completed our work, and this technology is available. Recently, it is certified by ICR also, sir. Thank you, sir. Thank you so much.
Development and characterization of biodegradable packaging material from banana plant waste.
Rishikesh Patil.
Wait 5 minutes.
So, good morning. Yeah, this one. Good morning, one and all the delegates present here. today I am going to take you through the commercialization of one of the most abundant biomass in India. So this is the development and characterization of biodegradable cutlery from banana plant waste. So I am Rishikesh Patil, currently working as a SRA in CIAE, Coimbatore. So research question: is it possible to replace the single-use plastic material with efficient biodegradable cutlery material without compromising its aesthetics and all of the properties? So yes, it is possible. So we can see around all of the plastic cutlery available in the market, only 10% can be recycled, and 90% of the cutleries available are going into the waste. So see the significance of the research. So we can see the market of the disposable cutlery was around $11.8 billion in 2023. So India alone generates 5.5 million tons of single-use plastics. So we can see the depth of the problem situation over here. So banana agro-industrial waste. So around 25 billion banana trees cultivated.
If you go by this, you will not finish in 5 minutes. So
Okay, sir.
go to the important slides only.
Okay, sir. Okay, sir. So I'll focus on how much waste is available in India. So 80 million tons of banana pseudostem waste annually generates in India. So that we undertook this research. So objectives are development of biodegradable cutlery material incorporating banana plant waste, and to characterize the developed material. So the design of experiment we did is, already preliminary trials were done, and we just finalized for checking the efficiency and other properties. So we used 30% of weight proportion, banana sculpture, then rice bran, then refined wheat flour, and the water as a plasticizer we used in developing of the cutlery. So first three treatments are of banana sculpture, which yesterday Dr. Naik sir presented the fiber extraction process, and one of the professor asked them that what you will do the waste which is generating during the fiber extraction process, that is called as sculpture. So I am taking over that. So that sculpture is utilized over here. So the next 44, T5, T6 are the same weight proportions, but by using banana dried leaf. So the developed cutlery is, the density of the developed cutlery is around 1200 kilogram per meter cube, the T1, and all of the developed cutleries are in similar results which are already developed. So sisal fiber based composites, they are weighing 890 to 950 kilogram per meter cube. So water absorption test, as this is completely bio-based material without any treatment or without addition of any synthetic polymer, our material is showing quite high water absorption percentage, which is around 100 or something percentage. So in another researches, there are untreated banana sisal epoxy composite, which in 40 and 60% composition, they are getting 49% of water absorption percentage. Flexural strength.
Go to the result.
Yeah, it is better if you
Go to
concentrate on.
conclusion now. We understood what you are doing.
So conclusion is, the cutlery development cost of 10-inch plate it's around 4 rupees right now we are getting, and the existing areca leaf cutlery cost is getting 10 rupees. It is available in market. So T1 I recommend the best treatment, but the thing is, the current constraints are we have to optimize it for hydrophobicity, as we can apply coating material. That too, there are not so many options are available which are completely bio-based and biodegradable. So I propose to, we shall research on developing some bio-based coating material.
Okay, thank you very much.
Thank you, Patel.
So we have developed biodegradable cutlery and presented to the governor of Tamil Nadu. So that was, and a lot of commercialization going on through this project, which is a NSF funded project in CIAI. So this is the video if you are interested. 1 minute. Okay, sir. Thank you, sir.
One question. Sir. Is any mic there? No, sir.
T-shirt. Banana T-shirt.
Yes, sir. Yes, sir. Banana shirt, banana sarees, all of the materials are already available in the market.
Developed at which place?
Developed at Ranchi,
Huh?
Ranchi, NRCB, Banana, Trichy,
Tirchi. National Research Center for banana है ना?
Trichy.
हाँ, Tirchi.
Yes, sir.
And before that, before Tirchi,
Before Trichy, I
Europe
don't
में
know.
ग्रेजुएट नहीं किया है. Philippines.
Philippines. Okay, sir.
Banana T-shirt, gamcha, many things are available from the banana fiber. And this is called economic, circular economy of banana.
Yes, sir.
Are you aware of circular economy?
Yes, sir. Yes, sir. Yes, sir. 100% utilization of the.
Banana.
Yes, sir. Yes, sir.
Everything.
Yes, sir.
Just for the information of the house, we are going to use the banana crate in making our consumers very soon.
Thank you. Thank you all.
Next speaker is Vaishnavi A.
So on behalf of Vaishnavi, I am P. Hema Shankari, is working as a scientist in ICR IAMR. Vaishnavi is the SRF in our institute and she is not able to attend this conference. So on behalf of her, I am presenting her paper, sir. Okay, sir. Okay, sir.
Introduction, materials and methods and people.
Yes. Sir, actually, this is next. So this is actually, sir, we had a review like paper, sir. We wanted to present on valorization of millet byproducts, creating value-added ingredients from milling waste. So as we all know that millets are two types, major millets and minor millets, and major millets are sorghum, pearl millet and finger millet, and minor millets are little, proso, kodo, proso, foxtail, barnyard and brown top. So valorization is the process of transforming the byproducts, waste materials or low value raw materials into higher value products, and it involves innovative ways to repurpose or enhance the worth of these materials, especially in the context of circular economy practices. And this is important in food systems and its sustainability, and many economic benefits are there. It creates a new revenue streams for food industries by developing innovative products from what was previously considered as waste. So it enhances the nutritional value, it reduces the food waste, and it promotes the circular economy. And typically millet undergoes a series of processing treatments before being consumed and intended for the development of value-added products. And millet byproducts includes bran, husk, broken grains. Up to 35% of the total weight of millets goes as a waste. Because of the outer covering that is present in the kodo millet. For example, the kodo millet has 7 layers. And because of that, 35% of the total weight of the millets are of waste. So bran is derived as a byproduct from the processing of cereal grains like rice, wheat, oats, barley and millets, and research, utilization and marketing are also concentrated for rice, wheat, oats and barley. So foxtail millet has a husk content of 13.5% and a bran content of 1.5 to 2%. And barnyard millet has a considerable higher bran content of 23%. So oil can be extracted from barnyard millet, and kodo millet shows even a higher bran content of 37%. And sorghum contains germs and pericarp percentages of 9.4% and 6.5% respectively. So these application to millet byproducts, millet byproducts are mostly used as animal feed and are rarely utilized in product development. And these byproducts are rich in bioactive compounds such as polyphenols, flavonoids, oligosaccharides, bioactive peptides, micronutrients, fiber and antioxidants. So the nutritional composition of millet byproducts can vary based on factors like milling levels, milling variety, millet varieties and weather conditions during growth. So these byproducts can be used for food as well as non-food sectors. So we are trying to focus on gluten-free baked foods, functional foods and supplements, and extraction of bioactive components for like water-soluble cylon, polyphenols, antioxidants, fiber and essential oils, and food fortification. Here, bioactive peptides derived from millet byproducts can be incorporated as ingredients in fortified food products to enhance their nutritional value. So, dietary fiber enhancement can be achieved by these millet byproducts, and natural antioxidant source is also one of the resourceful of millet byproducts, and gluten-free ingredient applications by use of gluten-free flour blends. So the pros and cons of economic benefits of valorizing millet byproducts are pros are new revenue streams, reduced wastages, enhances resource efficiency, job creation opportunity, and supports local economies and increases market competitiveness and increases market and cons are initial investment cost is more and it requires skilled labor and potential market saturation is there and regulatory challenges are there and need for consumer education and variability in byproduct quality is there. So the development of value-added products from millet byproducts are nutritional, market awareness, sustainability and regulatory hurdles. So millet byproducts are rich in essential nutrients and provide...
Madam, come to the methodology.
Yes, sir. So innovative use of millet husk. So it can be used to enhance the nutritional profile of bakery products, boosting the fiber content in the bakery products and utilizing millet husk provides a sustainable alternative to synthetic fibers in food applications and synthetic fibers, polydextrose, locust bean gum, enzymes such as phytase, alpha amylase and xylanase can help improve the quality of high fiber bakery food. Yes, challenges and solutions in valorization process, standardization of processing methods is a hurdle and economic viability strategies are there and regulatory framework development. And two case studies we have discussed is it is the utilization of millet bran in bakery products and it is a quality assessment of a nutri-cereal brand-rich fraction enriched buns and muffins. So buns with 20% of foxtail millet bran and muffins with 30% Kodo millet bran can be made and the objective is to formulate a designer buns and nutritional improvements, increased dietary fiber, enhanced nutritional quality and carbohydrate reduction, glycemic index, shelf life, storage, and this is the next case study. Here the foxtail millet husk to buy.
Kindly show the conclusion.
Yes, sir. Yes, sir. So the results are optimized UAE. Yes, sir. Yes.
Last slide. Thank you.
Nestle. Okay, sir. Put in as well. Stakeholder collaboration can be made, and these are the references for these studies.
The millets are very important, so if anybody is having any one question.
Because we are adding in food products.
Yes, sir. So we are trying to find out the anti-nutrients and the level of substitution, sir. Yes, sir. Yes, sir. Pre-treatments are being done to decrease the anti-nutrients like the soaking, steaming, enzymatic treatment, so that the tannins and phytates level comes down. Thank you, sir.
Thank you, madam. Next speaker is Archana Y. Kala. Uday Kumar Nidoni.
The next is development of sustainable packaging materials from agro-processing waste. Ajay Chaudhary.
Good morning, respected chair, co-chair, dignitaries and participants. 11. Okay. So this is development of sustainable packaging material from agro-food industry waste. So mainly the introduction, there are 630 million tons of agriculture waste we are producing in our country. In that you can see 32 million tons we are burning in our land. And there are many demands for making sustainable packaging material. considering our food processing industry waste as well as agro processing industry waste, there are a lot of opportunities to develop sustainable packaging material from these materials. In our studies, we have selected the agriculture waste material paddy straw, wheat straw, and agro processing industry waste material rice bran, wheat bran. And apart from that, we have selected that cotton seed cellulose material. So these are all the three basic materials which has been used for developing our sustainable packaging material. So here if you see that paddy straw material, we want to separate that cellulose, and it has more hardness when it is in the dry condition. So when we want to get the soft cellulose, we have given the alkali treatment with a different concentration. We got the fine cellulose material that will be used as a binding materials in our sustainable packaging material development. So this is the different pictures of paddy straw and wheat straw. And apart from that, we are getting a lot of waste from the minor forest produce, that is the bamboo waste. So there are many industries are available in Coimbatore district. They are converting this bamboo into different ornamental purpose or food application also they are using. So that time we are getting lot of waste material, and this waste material also getting a lot of cellulose, and those materials also can be used in the development of sustainable packaging material. Another thing, we selected that rice bran and wheat bran. Here also we selected both the defatted rice bran and fatted rice bran with oil content, without oil content, because without oil content it is sent for the poultry animal feed. So both the things we have selected. Here when we make any cutleries, these half odors, that rice bran and wheat bran that has the half odors, and that we removed it by using the green technology ozone treatment with a different concentration, and we removed off all the off odors, and when you add any food items in the cutlery, you will not get the off odors of those materials. So that is another thing we found. And also when we tried with a different concentration of that ozone, we found the changes in the carbon oxygen bond because of its highly oxidative agents, and also we found changes in the carbon nitrogen content. This is the equipment we have developed in-house in Tanjavur, and it was commercialized in Tamil Nadu also, and there are many requests for this equipment. Mainly it consists of hydraulic pump and different kinds of dies, female mode and male mode, and also control systems. And this is the complete plant. For example, if you have some 5 to 7 lakhs, you can set up one edible cutlery or sustainable packaging material unit. It has the mixture, dough cutters, and hard pressing equipment. And this is the small video, 1 minute. Yes, sir. Just one second. Can you? Yeah. So these are all the materials we can make. Can you move it? Yeah. Move it fast. So here we can set the pressure and the temperature, because we tried with 175, 200 and 225 kg per centimeter square, and also the temperature starting from 150 degree to 200 degree centigrade. With a different temperature and pressure, we optimized the different kinds of sustainable packaging material. By using the same machines, we can make the trays, cups, and plates. We can make it, and this will solve the problem where we are using single-use plastics in our food applications area. You can keep the hot water which can stay for 20 minutes, and if you keep the cold water, it can stay for 45 minutes. So that is the thing, and it is very compact material. You can make different sizes, different shapes of the cups and plates by using this technology. Yeah, it will absorb. That we studied that oil absorption, water absorptions also, but even that tea we can serve it, that can be used. So we tried with a different combination of that bamboo cellulose powder and rice bran, wheat bran with a different particle size starting from 1 mm to 6 mm. So whenever you have a smaller size, that particle size, so that time the dough formation is very nice, and that time the hardness of the material also we found very high in the sustainable packaging material. we conducted the rheological study of the dough and the hardness of the developed packaging materials. And here the main intention is that raw material combination as well as that what is the pressure and temperature you are setting, that is very, very important. Otherwise you will get the wastage, and this wastage again you can use it for the raw material mixing. And you throw this material, it will degrade in 45 days. The animals can eat, cow or goat, even chicken, it can eat this type of materials. And it is environmental friendly and less carbon dioxide emissions in the in our system. And this oil absorption, water absorption also very less when we go for higher pressure, the 200 kg per centimeter square at 175 degrees centigrade. The retention of it makes like hydrophobic material, so that oil absorption, water absorption will be lesser. And also that breakage strength, it comes up to 1 kg, 819 grams you can hold it, so it will not easily break up. So that is also another studies we have conducted with a different, and also that water absorption by using that contact angle method we observed. So in such a case that 175 kg per centimeter square and 200 kg per centimeter square will have very hard surfaces that will not have any porous structures. So in such a case that moisture absorption also very, very less in that. So here you can see the clear images of that porous structures of that cut section of that edible cutlery cups.
Try to sum up, sir.
Yeah. Also there is differences in the carbon hydrogen bond when we check that FTIR value in the developed, and also that GCMS, because we found some of the ester components, it's a rice bran and wheat bran,
Go to the
it has
conclusion.
some component is there. And also biodegradation test we conducted in 45 days, it will be completely 90 and above 90% it will be completely degraded, and the carbon emission value also very, very less. And the cost of 1 cup, the 250 ml juice cup is 2 rupees it is coming, and the cost of that tea cups, smaller one, 150 ml, it comes 1 rupee only. So it has a very good market potential. And our expert committee, they have evaluated our systems. 1 rupee, but plastic cups also sometimes 1 rupee 50 paise, 2 rupees coming, because that will depend on raw material also, so that can vary. And we demonstrated our technology in the last World Food India also. Our Minister Bhavan sir also visited, and DDG sir also visited our stall. It was accepted by many people, and we transferred this technology, and there are many requests for this kind of product in our market also. So thank you very much.
One question.
This technology is available for the
First? Yes, sir. Yeah, it is available. Yeah, it is commercial. We given this technology to 2 companies in Tamil Nadu, and there are many companies. We are also manufacturing this equipment also. It's our patented technology. Maximum 7 lakhs. If you have 7 lakhs, you can set up the one plant, and per hour you can get to 200 cups per batch. 10 cups you can get it. Per hour, 200 cups you can get it.
I have just one query. This machine developed, is it available like anybody can buy?
Yeah, they can.
Yeah, this is one thing. Second thing, like if you want to increase the water absorption, can you go for these food
grade, for example,
wax, food grade wax?
Yeah, that we can, for example, carbon wax, honeybee wax is there. Even the soil is in that we can apply as a coating material. That will improve the barrier properties of this packaging. That is,
it's a good work. Thank you.
Thank you. And one more presentation also continue.
It was together.
No, this is another work, sir.
Can you show only 2 slides?
Yes, sir. Yeah. The 012. This is 011. This is 012. This is another work. Actually, I am working on the packaging area for the last 8 years. So we developed the Enable Aggregated Lab also. So my work is fully on packaging, and in our country there is lot of demand for food packaging specialists.
So it will be good. No, you just focus on that conclusion slide.
Okay, sir.
You can tell anything while
so
reading
just
that.
I will go through. Here the problem is that thermocol. Now the India banned using this thermocol in many of the applications, because the collection of thermocol and recycling is the very, very big issues. So we developed some technology alternative to thermocol. So here what we did, we have taken that paddy straw and wheat straw, and we given that ultrasound and pulsed electric field. So similarly, to makes that cellulose very porous structures. So this two non-thermal technology has been introduced. And after that, we evaluated that cellulose content and that fiber length, all these things of treated pulsed electric field and ultrasound treated materials. And because of that, we found this ultrasound treated that 550 watts and as well as that pulsed electric field 40 kilowatt per centimeter, that gives higher amount of that cellulose content as well as that higher amount of lignin removal content. So these two things are very, very important when we make the particular shape or the particular color of this material. And also we evaluated the same images of all these things. So here the good thing is we have taken that mushroom. From the mushroom, we have taken that a small part of that mycelium, and we cultured in our microbiology laboratory. And we, in 7 days time, we can get the growth of this mycelium based culture. And we transferred into the agriculture waste material, which has the complete set of dye. Either you can make a circular shape or you can make like a tray shape. So there you can fill it. This is the control sample. We didn't get the result. But if you have ultrasound treated and as well as the pulsed electric field treated, you will get the foamed material. So this foamed material, you can use it for the secondary packaging material for keeping some bottles, cushioning material, particularly in the transportation. If you want to cushioning material, that you can make it. So these are all the results of that functional properties, physicochemical properties, as well as that mechanical properties we have calculated. So these are the final findings that the 10% alkali solution treated will give very good results in lignin removal as well as good cellulose percentage getting. And apart from that, considering that pulsed electric field and ultrasound, 550 watts, that ultrasound treatment as well as 40 kilowatts per centimeter. So that pulsed electric field treatment given a very good results in making a cellulose extractions. And these materials, after using that, comparing that oyster mushroom and button mushroom, oyster mushroom has given a very good result forming that mycelium at 25 degrees centigrade and 75% relative humidity. So that you can make this type of materials, and that can be used in a different food contact materials for transportation purpose. There you can use it.
Thank you. Just one question, quick question. Yes? Yeah.
Yes, sir.
Yeah.
I will request the honorable chair to include one recommendation from Bidwar to Central Agriculture University of Bihar that it is handled this stuff adopted there because it's a large area where variety of bamboos are used in Northeast. So I suggest you that make a good report with
For consideration of the policymakers.
Sure, sir. Here they are collecting feedback form, there they can write it.
Yeah, but you give your from your side, whatever the important of that.
And you make mention of that what you are talking.
Sure, sir.
Because this one should go to different places. This is already there.
Sure, sir. And anybody interested, you can approach. We are ready to transfer this technology.
Sure.
Thank you very much, sir.
Thank you.
Our online presenters are ready?
Yes, sir.
Yes, sir.
Oh, now give.
Praveen GM, first one. Number 3.
Number 3 presenter, Praveen GM. Are you there, Praveen?
Characterization of a natural edible film obtained from tamarind seeds, starch and application in food packaging.
पुढे चल बघू का अर्चना महापात्रा is there?
Yes, sir. Yes, sir.
6th number, sir.
Green recovery of lemongrass essential oil with hydrogen bondage supramolecular eutectic solvents.
Yes, sir. I'm present.
Go ahead.
So time someone.
3 minutes.
Okay,
You-
sir.
You have to finish, just talk about what you want to give message to the audience.
Okay, okay, sir. Okay, sir, I'll finish in time. Thank you, sir.
Kindly make it in presentation mode.
It is in presentation. Is it visible, sir?
Yeah, but it is slide mode, not in presentation mode.
Okay. Mm. Is it now in presentation mode?
No, either you can go for increasing the size also you can go.
Okay, sir.
It's okay, yeah. Go ahead, please.
Okay. Okay, sir. Good morning, everyone. Respected chairman, co-chairman, and delegates. I am Archana Mahapatra, scientist at ICAR NISA Ranchi. And as can be seen, the topic of my presentation is green recovery of lemongrass essential oil with hydrogen-abundant supramolecular eutectic solvents. So coming into basics, I am not going into details of essential oils because all of us are knowing about it and we are sometimes using in our everyday life also. This possess various properties because of which these are mostly used in the food and beverage industry, perfumery and cosmetics, mostly used in aromatherapy, healthcare, as well as in pesticide and for repellents. Now coming to lemongrass, it belongs to the grass family and it contains essential oil on around 1 to 2%. The essential oil content usually varies based on the season. So in summer, usually the oil content is more, whereas in
If you go directly to your finding, it will be better because you have to finish
Yes,
in
sir.
3 minutes.
Yes, sure, sir. And it is used in culinary applications as well as repellents. So conventional extraction, usually using steam and hydrodistillation, has various, although it is industrially widely used in industries, but it has various constraints like especially the time and energy consumption as well as the quality of the oil.
Archana,
So,
go to
yes, sir.
results and conclusion. Results and conclusion.
So in this we have taken three different choline chloride based eutectic solvents and assisted with hydrodistillation, and as can be seen the properties of DS were characterized the pH when with the oxalic and citric acid the pH was less than 1, whereas for CSCl urea resulted in an alkaline pH. The freezing point can be, as can be seen, although the freezing point of the individual components were more than 200 degree, but with an eutectic mixture, the freezing point was less than 100 degree. And now coming to the, we also did the rheological studies of this, and shear thinning property was absorbed with the increasing viscosity of the these DES mixtures. Now coming to the yield of lemongrass, as can be seen the control one where it was done with only extracted with hydrodistillation. The extraction time to receive 1 ml lemongrass essential oil was 180 minutes, whereas it drastically reduced by around 50% when using the DES mixture of choline chloride and urea. However, with this use of this, the DES mixtures, there was a slight change in the color, darkening of the color, which may be due to the also the extraction of other phenolic components and other components from the leaf extracts. Antioxidant and total polyphenol content of the lemongrass essential oil has also been evaluated.
Come to the conclusion, ma'am.
Yes, sir. And the extraction time reduced by 47%, 27% and 39% respectively with hydrogen when using different DES mixture. The best result obtained using urea, choline chloride based DES followed by citric acid based DES. And the EOS functional properties were retained best in the urea based DES mixture followed by citric acid and then oxalic acid as compared to the controlled essential oil. So this is a preliminary study actually, sir, and based on this result we are taking further and going to do and further analysis are going on. So based on that again the process will be optimized. So
Thank
that's
you.
all, sir.
Thank you, madam.
Mr. Poddar PT, development of paddy straw based biocomposite packaging material for fresh produce.
Yes, sir. Is my screen visible, sir?
Not it. Yeah.
Yes, yes.
So you have 3 minutes. So concentrate on the first slide, middle slide, and the last slide.
Okay, sir. So, welcome all. The topic for my presentation is development of paddy straw based biocomposite packaging material for fresh produce. So, in layman terms, what biocomposite material is, it is a combination of, we can say, natural fiber and biopolymer. Biopolymers can be synthetic as well as biodegradable. So, the need of developing this material was to eliminate the uh, synthetic plastic materials which take longer time for degradation. So this the natural fiber taken for this study was paddy straw, because we all know the problem of stubble burning or paddy straw burning in the Punjab. So we took this natural fiber. This study was conducted in 3 steps. First was optimizing the pulping process of the paddy straw in order to remove the lignin from the paddy. Delignification process was conducted in order to make it easier for paddy straw to mix with the other composite materials. So this experiment included treatment of alkali concentration. We took 5, 10 and 15% alkali concentrations. Temperature was 45, 50 and 55 degrees.
I think please go to the conclusion, Pratik.
Okay. So for this first step.
Conclusions.
Yes, sir. So for the first step, the optimized concentration, 14% sodium hydroxide was there. Treatment temperature of 53 degrees Celsius and time of 240 minutes. For second step, we mixed with this treated paddy straw with the 3 different plastic materials, PVA, PLA and PBAC.
Please conclude.
Okay, sir. For the 3 different materials, for first material, the costing of the material was 0.67 rupees per gram. For second material, it was 1.31 rupees per gram, and for third developed material, the price was 0.92 rupees per gram. I'm coming to the final conclusion of the storage experiment. So for the storage experiment, the 3 developed packaging materials enhance the shelf life of stored button mushroom by 5 days. In market available packaging materials, the storage life was only of 3 days, but in the developed packaging materials, the shelf life enhanced by 5 days, and we were able to store it up to 8 days. So for final conclusion, we can say paddy straw can be effectively incorporated as a natural fiber for developing biocomposite materials. Alkaline pulping improved the quality of paddy straw.
Yes, I think we can read all that. Okay? Thank you.
Thank you, sir.
Thank you.
The third.
Mr. Praveen GM is available online? Is available?
Praveen, that third number.
Characterization of a natural edible film obtained from tamarind seed starch and application in food packaging. Is available? Online.
Arul Mari, please share your presentation.
Sir, actually, Sudhakar sir, I don't know sir, whether he is presenting or not.
Okay, thank you very much.
Okay.
Good. What should we do? I think she has
Yeah.
raised a hand.
Yeah, we are having neem-based pesticide formulations, post-harvest utilization of a valuable forest crop and future prospects for agro entrepreneurship. Charpe AM.
Sarpe madam, can you hear us?
Good morning, sir.
Madam, show your slide present. And
Yeah, I am sharing my screen, sir.
Yeah, you are.
Yeah.
You are having 3 minutes, so just tell the importance of what finding you are having.
So is it visible there?
Go to the slide mode.
I have shared my slides. Is it visible there?
not visible. There may be some internet issue at your end, madam.
I think you just tell orally because slide there is some problem in sharing. You can read the abstract.
Okay, sir. Yes, sir. Yes, sir. So neem-based pesticide formulations and the possibilities of agro-entrepreneurship is my topic. And here I want to highlight that Azaricta indica, which is commonly known as Neem margosa, neem tree or Indian lilac,
Come
is
to the
very
objective.
rich in pesticidal properties.
Come to the objective, madam.
Yes, sir. The objective is, actually this is a review paper, sir, and I want to highlight the importance of neem and how it can add to the entrepreneurship to Indian economy. And here, this actually I had shown a distribution map of neem. It is indigenous to
Madam.
Southeast Asia, and except Himalayan
Madam.
region, all over India it is
Madam,
grown.
can you hear us? Kindly come to
yes,
the
ma'am.
conclusions.
Yes, sir. Yes, sir. I will give the conclusion. Just one introductory part that many phytochemicals are present in different where azadirachtin in azadirachtin is the most important component which is used in agriculture, veterinary medicine as well as health sector. And for extraction, it is extracted with ethanol. The solvent extraction is used, and limonene triterpenes are used for preparation of pesticides, although from diverse sources when they are isolated there is
Madam, we are
possibility
running
of
short of
contamination
time.
agent.
Please show your conclusion and thank you.
Yes, sir. So there are microencapsulation possible.
Conclusion.
Conclusion is that, sir,
Last
in
slide.
India, conclusion is that in India we are having 20 million neem trees all over India, which can yield 3.5 million tons of neem kernels. From neem kernels, when we extract neem oil, 7 lakh tons of neem oil can be extracted. And
Madam, if you are not going to conclude, we will mute you. Kindly
the
conclude.
conclusion is, sir, it can add to our economy as per 250 rupees per kg price of neem oil in the current market. If we channelize our resources properly,
Okay, thank you very much. Thank you very much.
175 billion rupees business it can provide. And if azadirachtin A is isolated, then 8.9 trillion rupees annually, which is almost 3% of GDP can be tapped out of this business, sir. Thank you very much.
Thank you. Thank you. I think now. Over. Now we present 5 minutes.
Respected Chair, rapporteurs, distinguished delegates.
I am going to speak about utilization of food processing waste, innovations and technologies. Next. Actually, when you look at the crops that we grow and the kind of portion we take for our food, it is only 1/3. And 2/3 is agricultural biomass or agricultural waste, which is being burnt nowadays. And there is a great potential to use them in different forms, as we have seen from the reports of different scientists. Similarly, when we have the edible portion harvested, when we process it, then in processing, there are 50% losses. That 50% becomes waste. if the process is not good, and mostly in the third world countries, it is 50% are waste from the processing and 50% only we get the edible portion. Whereas in the Western countries also, where the processes are very highly mechanized, very efficient, and still they have 20% of the waste generated in the processing. For example, when you process rice, you have husk, you have bran, then the bran percentage will vary based on the machines, and the efficiency will be depending on based on the technology we are using, and that is why all these waste should be used properly. Next. So this shows that this waste which is generated during the processing for making food for us can be used further to extract very high value products. For example, from the rice, we have the rice to eat, but the rice bran oil, it is highly useful, very healthy, and it gives more price to the farmer many a times rather than the main crop. Similarly, for horticultural crops, if you take maybe mango, you get a pulp, but along with that, when you get that peels and stone, that stone starch is so valuable that in Europe, they make the winning food out of it for the children. And that is why this waste is wealth actually, and we should have develop the technologies to process this waste into wealth, and as well as to promote it for industrialization. Next. Next. This is the importance, environmental and economical implications. Next. Nutritional and health advantages of the byproducts. For example, mango seeds rich in oleic acid, pineapple peels high in dietary fiber. Next. The nutritional and health advantages of the byproducts. These are the different byproducts of the horticultural crops, from mango, pineapple, banana, and all different crops, and what nutrition they have. Byproducts, peels, what nutrition they have. Next. Then technological innovations in waste valorization. There is a fermentation process which is generally used to extract the nutrients, extraction of bioactive compounds, like cold pressing technologies, solvent extraction technologies, isolation of flavonoids, phenolics, development of functional food ingredients from these extracts. Next. Then this is a circular economy, what we call it, that our waste is the byproduct which is from the processing industry, and also the second grade products. Because the tomatoes, when they come to the processing industry, the total quantity of the tomatoes are not that good to be used. There are many spoiled tomatoes, and they are also a kind of byproduct for us to use further for extraction of lycopene and peel ingredients. Next. This tomato processing waste, there is a great potential to have that. This is a grain processing waste. Next. Tomato processing waste, then grain processing waste like bran, germ, husk, hull. It can be incorporated into the bakery products to make them more healthy. Then next. Then application of grain processing waste, dietary fiber fortification के लिए use हो सकता है. Extraction of functional ingredients use निकाल सकते हैं. Then biofuel or biogas production also can be done if it is very low quality of the byproduct if you get. Next. Then these are the case studies in our country. The mango seed and mango peel extraction industries are available in Karnataka. Tomato waste processing in Maharashtra is going on in the big way. Then rice bran oil extraction and applications there, it is very common in Punjab and West Bengal because they have more of rice mills, so they get easy access to the rice bran, and then from that the rice bran oil is extracted and made it available to the people at much expensive rates. Next. Then citrus peel and pectin essential oils. The juice processing units in Andhra Pradesh, they have established these units. Actually, this technology has not remained only in the research laboratories, but it has been taken up by the industry for further processing. And these are the case studies we have. Then banana peel processing in Tamil Nadu. In collaboration with Tamil Nadu Agricultural University, they produce the banana peel powder, and this powder is incorporated into fiber-rich biscuits and healthy bars. Then wheat bran as a dietary fiber supplement in Punjab, because Punjab, we know that it is a grain bowl of the country and lot of wheat is produced in that, and then wheat processing units are also there, atta making units are there, and then wheat bran Several Punjab-based companies have developed wheat brand supplements marketed for their high fiber content. These supplements are incorporated into the bread, noodles, baked products, enhance the dietary fiber intake among the consumer. And these byproducts, when they are processed, they are not only having the market in India, but they have great market abroad. So mostly they are export-oriented units. Next. Then insights and future direction, potential to address the global challenges of hunger, malnutrition, vast potential for utilizing food waste in this country because we grow and we produce lots of food grains as well as the horticulture products, and that is why we have the strength with us to get the byproducts also in the large quantity and to have the industries based on that. Need for collaboration between government and also the research institutions. So these are the conclusions. Strategic utilization of food processing waste. It will have the environmental, economic as well as nutritional challenges. Advanced technologies are being developed for transforming the waste into valuable resources. Case studies, they demonstrate us that it is a feasible and somebody wants to go for it, it is possible. Then importance of innovative reuse of food processing waste for long-term sustainability. Potential to address global challenges. Need for collaboration between the government, research institutions and the private enterprises. Next. With this, I thank you very much for giving me this opportunity.
Thank you, sir. Thank you, Dr. Patil and the chairman of today's session. Yes.
Good morning and welcome all the audience, chair, dais, and with the permission, though we are running late, I will not take more than 2 or 3 minutes, but I will give you the importance of that. And my topic is, though yesterday many of you might have heard about the nutraceuticals, and everybody is facing the problem of nourishment. We are fed with the drugs. Though we want to cure for any disease, but then the parallel side effects are there. And if you want to nourish yourself, and by nourishing to flourish, I can just give you maybe 2-3 slides. The nutraceuticals is divided into the 4 segments just for our understanding. It is the food or food components that provide health benefits beyond the nutrition. Beyond the nutrition, whatever food we are taking, it may be giving us nutrition, but if we need some deficiency somewhere less, it will give beyond that. Second is available in forms such as capsules, tablets and fortified foods. This is very important. When we say the nutraceutical, it shall be in this form as per the definition. Include a wide range of bioactive derivatives. So far today and yesterday we have come across so many different words. Antibiotics, flavonoids, then prebiotics, probiotics, all those things comes under the bioactive derivatives. And the fourth is covers a therapeutics area such as osteoporosis, blood pressure, like whatever kind of the diseases or the abnormalities we are having in the body, it covers all those areas. Though it looks like for us nutraceutical is a new area, it is not. We are using since our so many old days. For example, if somebody gets the cunt in the home or anywhere, and if you don't have anything, even people used to put the turmeric powder. So it starts, even if you go back, you will find so many things. If you go to the tribal areas, they are having so many herbals, and we don't pay attention to them because we think that it may not be good, but it is that old. The only problem was availability, affordability, safety, and their belief. And that's why it was not popularized. Now, because of this development in science, we are having so many things and we are getting it. Now, today, if you see the definition, the use of nutraceuticals by people, though quite old, its potential effective use started in 1990s, just 3 decades back. The term nutraceutical was coined first time from nutrition and pharmaceutical in 1989 by the scientist Stephen D. Fellis, who was the founder and chairman of the Foundation of Innovation in Medicine in USA. Nutrient is a nourishing food component and pharmaceutical is a medical drug. It is a combination of the two words, nutrition and pharmaceutical. That is, a drug is also there and the nutrition is also there. Now, over the last 3 decades, it has been shifted. The viewpoint has shifted basically drastically in recent times from one of treating diseases to one of maintaining good health. Like many people take the nutraceuticals even if not just to cure disease but to keep yourself fit. I just want to tell, the nutraceuticals are basically classified based on their source material, and they are having 3 sources. Plant as a one source, animal as a another source, and the third is the microbes. And you get the different bioactive derivatives from these, and with the help of drugs, you can make a good nutraceutical product. Just for the knowledge of the house, vitamin C, vitamin B1, vitamin B2, vitamin B3, B5, B6 and B12. In the pharmaceutical industry, everybody is making money with the vitamin B12. Everybody out of 100, 90 people is having the deficiency of vitamin B12, and it is not that important the way we are spending on it. It is required in 0.005 milligram per 100 gram, and it is many times, if you are having a good diet, it can be produced by the body itself with the combination. Vitamin A, D, E and K, these are the fat soluble vitamins and their health benefits. Minerals: calcium, iron, magnesium, phosphorus, cobalt, copper, iodine, chromium, selenium and zinc. Zinc has helped us to fight the corona. Zinc has helped us to fight the corona. To develop the immune system, you need to go for the sources, food material which are having a good zinc. Then we know everybody of us are acquainted with this: garlic, ginger, turmeric, tomato, ginseng, green tea and aloe vera. This is what I want to tell. For these nutraceuticals, there are not very good regulations. First thing, regulations varies from country to country, and even the terms or their definitions are also varying from country to country. And we need to get acquainted as far as our country is concerned. So, nutraceuticals are regulated differently in different countries. The regulation focus on safety, labeling or good manufacturing practices. Some countries use a registration-based approach, while others use a notification-based approach. In India, the Food Safety and Standards Authority of India regulates nutraceuticals, requiring approval before manufacturing or selling. Nutraceuticals must meet safety first and then quality standards, including limits for contaminants and adherence of good manufacturing practices. These are the different terms comes under the nutraceuticals as per the FSSAI. The first is nutraceuticals, second is the health supplements, third is food for special dietary use, food for special medical purpose, and prebiotic food and probiotic food. FSS has revised their standards, which was in 2016, to the new in the year 2022, with so many removing the ambiguities in those. Just for knowledge, nutraceutical is a category of foods which consist of extracts and isolates. However, health supplement is a category of foods which consist of a concentrated source of nutrients, any 1 or 2 or 3. Then food for special dietary purpose is a category of foods which are specially processed or formulated to satisfy particular dietary requirement. Then foods for special medical purpose is a category of foods for special medical uses which are specially processed or formulated and presented for the dietary management of patient and may be used only under medical practitioner, that is normally in hospitals. Prebiotic food means food that contains added ingredients which are non-viable food components that confirm health benefits to the consumer by modulation of gut microbiota. Then probiotic means food with live microorganisms beneficial to human health. These are the definitions as per FSSI. Then these are the different requirements. First, they need to get the approval. They have to follow the safety and quality with the recommended practices. And the labeling, they need to follow the rules and they need to quote what that particular material is giving. That is very necessary. Then packaging and the claims. If somebody has to claim, they come under not make false or misleading claims about their health benefits. Any claims made on the label or in advertising must be supported by scientific evidence. Huge potential. We are coming up in a very big way, but still the way Patil Saab has told that we are full of food and horticultural produce and so many things, like when you are looking for deriving the bioactive compounds. But our contribution in the world market is just to the tune of 2%. And we are having a great scope to come up. These are the key players. And these are the challenges. I just want to take a minute here. There are good scope for all the group of scientists, whether you are looking from what angle, quality control or regulatory compliance, supply chain management or a product quality. And just I want to tell that nutraceutical is a combination of nutrients plus medicines and for providing vitamins, minerals, proteins, fibers, prebiotics, amino acids and so many other things concerned with the nutrition. Give physiological benefits or provide protection against different kind of chronic diseases. By using nutraceuticals, it may be possible to reduce or eliminate the need for conventional drugs and reduce the adverse effects. It is facing, the way I said, different challenges, and there is a good market for nutraceutical. And this is what I want to tell, it is a bridge. If we want to go from one side to the other, we need to combine them and the traffic will be much easy, flow will be very smooth. Thank you.
Any questions? Very interesting topic.
I just want to announce one point. Actually, after the end of this session, the next session will be conducted here. It is a common session for all of us. That is the theme session of convention. So, at the end of this session, the next session will start here, and all the groups will join in the auditorium. This all. Thank you.
Thank you. Thank you very much.
माइक दे दीजिए सर को.
Patil Saab, you talk about that computer and many things. So, you know, in the computer, chips are used.
Yeah.
And they are inorganic silicon.
Yes, sir.
And the speed depends on the quality and quantity of silicon in the chips.
Right.
But do you know anything organic chip, silicon?
Biochips are there in our body in many places.
No, inorganic chip that is used from Ethiopia. The US has a whole contract of the mines to extract the silicon for computer industry.
Yeah, that is for inorganic chips.
But for organic chips, I am telling you, organic silicon.
It is going on, sir. They are trying to do some organic chip work.
क्या आप कुछ
ये
बताओ?
जो है ना IT वाले.
For example, the rice husk we are
using
rice husk.
My computer chips. Computer chips. Acha, he has information about it.
No, I got the point. I am telling that the organic chips is silicon from the rice husk. You burn the ice, and from that you burn further. You get the silicon, which will be used computer, and the speed of the computer will increase further.
Plant-based silicon. Okay. We have announcement for the next session, which is very common session for all. It is engineering innovations on next gen digital agriculture. Chairmen are Dr. Indramani and Dr. Dharmendra Saraswat. Rapporteurs are Dr. Gopal Shinde and Dr. Dakore. And the lead speakers both are online for this session. Dr. Dharmendra Saraswat from US and Dr. Yasri Gohatiwar from MBK Rahul. With this, we thank you all for cooperating with us for conducting this session.
We were also having a good audience, though it was not full, but we enjoyed, and I hope that everybody, others might have enjoyed, and we could be able to keep our program in the scheduled time. Thank you.
So with this, we have come to the end of technical presentations. In today morning, we finished the sixth session. We are very much thankful to Honorable and respected Dr. R.T. Patil sir and Dr. N.J. Thakur sir, who have chaired as chairperson of this session. Actually, they are the great persons from whom we can take many lessons, both from their critics as well as their remarks also. Sir, we are very much thankful. On the behalf of organizers, I again extend my thanks to both of you, sir. Again, I am thankful to Dr. Divekar sir and Yadav madam for performing their duties as rapporteurs for this session. And after this one session is here, all the teams will join as a combined session. So from our end, thanks to all the participants who have participated and given the meaningful contribution to their discussion. From the audience and participants, I must mention the name of Dr. Nawab Ali sir. Sir, the Pitamas like you are there in our team, and as long as these Pitamas are there, we the next generation will always get benefited. Like you are there in our team, and as long as these Pitamas are there, all the participants, we the next generation will always get benefited. So thank you very much.
अच्छा लगा सर आपका टॉक, अच्छा लगा, आपने बहुत सारी चीज़ कवर की, वो थोड़ा मुझे कभी भेज दीजिएगा।
इसमें डाल दिया है।
अच्छा लगा सर आपका टॉक, अच्छा लगा, आपने बहुत सारी चीज़ कवर की, वो थोड़ा मुझे कभी भेज दीजिएगा।
इसमें डाल दिया है। पार्टिसिपेंट्स के लिए है, सबके लिए।
एकदम आगे एकदम आगे
धर्मन में वादिकारों के नातों से करा था, पूरे इसमें जीवन का रहस्य छिपा है।
सर आपको चलना
भगवान ने कौन सा महत्व सर कहाँ जा रहे हैं?
नॉलेज गेन करने जा रहा हूँ।
आप भीष्म